In this problem, we are to simplify the algebraic expression 6 times n cubed plus 5 times n cubed. It's at this point I want to remind you what multiplication is. Multiplication represents repeated addition, which means that if you have 6 times something, it means whatever that something is, in our case n cubed, you are adding that to itself 6 times. So when you see 6 times n cubed, you may think of that as you have 6 n cubes all being added together. Then a similar argument can be made that 5 times n cubed means that you have 5 n cubes added together. So I'm going to bring in 5 more n cubes. So think of this 6n cubed is sitting right here. 5n cubed is sitting right here. And the operator between these two terms is addition. So I'm going to put addition in here. So now, since I have 6 n cubes being added together here, and I have 5 n cubes being added together here, if you were to add them all up, that means I have 11 n cubes all being added together, and we can represent that repeated addition using multiplication. If we have 11 n cubes added together, that means we have 11 times n cubed. So with this, you can see that the shortcut that you probably have been taught is that if you're adding like terms, and these are like terms because they both involve n cubed, that you do nothing to the exponent. There's no multiplying of the exponents of 3 or adding of the exponents of 3. In fact, if you wait till the end of the video, I'll show you the context for which you're supposed to multiply or add the exponents. But if the two expressions are being added, the shortcut is to simply say that 6 plus 5 is 11. And that since they have like terms, you just keep that like term of n cubed. You basically leave the exponent alone. So 11n cubed is my answer. Now let me show you the context for which you wouldn't keep the n cubes, where you may multiply or add the exponents, just to remind you the difference between the types of problems where you leave the exponents alone when you multiply them or when you add them. So for example, had the problem been simplify n cubed times n cubed, this is the situation where you actually would add the exponents. You'd leave the base of n, and 3 plus 3 is 6. You'd say n cubed times n cubed is n to the 6. And this is because we're not adding the two expressions, we are multiplying them together. In fact, this means you have 3 n's being multiplied together, and you're multiplying by 3 more n's. So you'd have 6 n's multiplied together, not added together. And to denote that you have 6 n's being multiplied together, we would write that as n to the 6th. Finally, if you had a power of a power, you would multiply the exponents. What this actually means, because an exponent tells you how many copies of the base to make, n cubed cubed actually means 3 copies of n cubed being multiplied together. So you have n cubed times n cubed times n cubed. That's what this exponent of 3 means. Well, then if you bought that, then you'd see from the previous example, when you have this situation, you add the exponents. And that's the situation I have here, except I have n cubed times n cubed times n cubed. So rather than just adding 3 plus 3 to get 6, you'd have 3 plus 3 plus 3, which is 9. So I get n to the 9th. And this is why you probably learned the shortcut, that if you have a power of a power, you can take the two powers and multiply. 3 times 3 is simply 9.